Hello. So this is a couple of examples. This is from our Module 3 practice test. I'm sorry, this is from the Module 3 actual test. So I wanted to go ahead and do some examples with you guys and hopefully it kind of explains some things. So the first one I'm going to do is number 6. In which case we are multiplying a mixed number and an improper fraction. So multiplying fractions is pretty easy. We just multiply right on across. But in this case, they need to both be fractions. So we need to go ahead and it's almost like the very first step is to get them both in fraction form. So we need to turn this mixed number here into an actual fraction. We don't need to touch 5 over 3. That one's good to go. He's already in fraction form. But what we do need to do is 3 2/5. We're got to turn it into a fraction. It's going to be an improper one. So these notes are in the announcements or in section 3. This was like its own little section, which is step 1. Let's go ahead and convert this. So in order to do so, you take your you keep your same denominator, and then you take this 5 times 3 and then plus your numerator. And this works every time. It's the same procedure. So we have 5 times 3, which is 15, plus 2 more, which is 17. So we just turned, so that was step 1. We have to get them like into fraction form. The second step, let's do the second step. So then we have step 2. And this is pretty much just multiplying them right on across. So we do, you can do 17 times 5, which we'll do that over here. 5 times 7 is 35. 5 times 1 plus 3 is 8. So we have 85. And then 5 times 3 is 15. So that was the multiplication part. So then your last step, which is step 3, this is to simplify. So we've got to simplify this 85 over 5. And so we have to find a common factor that go into both. Well, I know for a fact that 5 can go into anything that ends in a 5. So I'm going to divide them both by 5. So 85 divided by 5 is 17, and 15 divided by 5 is 3. And so that would be your final answer. So that's number 6. So another one that was pretty commonly asked for help with is number 13. So this is very similar to number 6. However, we again are dealing with a mixed number and an improper fraction. So our very first step is we need to get them at least both in regular fraction form. So that's step 1 again. So divide, and I'm not going to touch this one. I don't need to. So we have 5 times 1 plus 4. So that's 9, and then we keep our same denominator. So to divide fractions, we use, we're on kind of, this is that next step. To divide fractions, we have to do what's called keep, change, flip. And so we keep the first fraction, change this to multiplication, and flip, or multiplying it by the reciprocal is technically what it's called. So we're going to keep this first fraction, which is 9 over 5. We're going to change division to multiplication. And then we're going to flip. Instead of 5 over 6, it is 6 over 5. Now we can just multiply right on across. So we have 9 times 6, which is 54. And we have 5 times 5, which is 25. Now, our last step here is they want the answer actually back into a mixed number. So for step 3, we need to simplify this 54 over 25. And we do this a little bit differently. We can't exactly divide them both by the same thing. They don't have a common factor. So what we have to do is convert it back into a mixed number. So if you have to ask yourselves, how many times can I take 25 into 54? And you can do this multiple ways. You can kind of do it by just envisioning it in your head, or you can do it by long division. I will show you what it looks like in long division. So how many times can 25 go into 54? Well, I know it goes in 2 times. Okay, so you can either put the 2 here, or you can envision a big 2. It's going to go in 2 times, because 25 times 2 is 50. And then we have this 4 remaining. So you can either envision it as here, where you can just tell yourself, oh, I know that 25 goes into 54 2 times, and there will be a 4 left over. Or you can do it via long division, where you can see that 4 would be the remainder. All right, the next one we're going to do is number 1. So we're going to switch gears. This is subtracting fractions, and it works the same as adding fractions, so same thing. So our first step here is let's go ahead and follow. There is another way to do this, but we're going to just kind of keep in our same procedures where we're going to turn these into improper fractions. Okay, so let's go ahead and just do that. 5, and this is going to be a denominator of 10. Okay, so we do 5 times 8 plus 4. 5 times 8 is 40, plus 4 more is 44. And then we have 10 times 5, which is 50, plus 1 more, which is 51. So that's kind of that step 1. So putting them into improper fractions. The next thing we have to deal with here is when we are multiplying and dividing numbers, when we are adding and subtracting. Okay, and these are right in the notes. But adding and subtracting must have common denominators. You can't add and subtract without this. Denominators. So we need to get a common denominator between my 5 and my 10. They don't have the same one. So I have to think of a number, this is step 2. I have to think of a number that both 5 and 10 have as a multiple. Well, we can go ahead and list the multiples of 5 and list the multiples of 10 and try to find one if we'd like to. So multiples of 5 are like 5, 10, 15, 20. And then multiples of 10 are 10, 20, 30, 40, that kind of thing. So I want to go ahead and find a multiple that they both have in common. Well, they have a few in common, but the smallest one that I can find is 10. So let's use that as our common denominator. All right, so it's kind of here, remember when we simplified fractions up in this example where we divided them both by the same and it made the fractions smaller? This is actually multiplying them by the same to make it bigger. So this denominator of 5, how did we get it to 10? Well, I multiplied it by 2. So if I do that, I have to do the same thing to the numerator. It's only fair. So 44 times 2 is 88. Now this denominator I didn't change. I can keep it 10, so I don't have to change the numerator. So once you have it in this case, now we just subtract and you leave the same denominator. So 88 minus 51. Actually, I'll do it in another color so that we can see this is a kind of another step. We'll do red. So this is step 3. All right, so we have 88 minus 51. 8 minus 1 is 7. 8 minus 5 is 3. So we have 37 over 10. So once again, our answer, it wants it in a mixed number. It wants it in these again. So we can do the same procedure we did before. How many times can 10 go into 30? So we can say, oh, it goes in 3 times because that's 30. We haven't gone over. Once we get there, there will be 7 left over. So then you have your final answer. All right, and the last one, I think I have time in this recording. Yeah, I do have 5 minutes. All right, the last one is this measuring cup question. So this is division. So we need to get 3 3/4 cups of flour, and we only have a measuring cup that measures 1/8. So we need to figure out how many times we have to use it. So when you have something like that, you're looking at a division problem. So 3 3/4, and we are dividing this 1/8. So in that previous example, we have, that step 1. We need to get this into, we need to get that into a fraction. So we have 4 times 3 plus 3. 4 times 3 is 12, plus 3 more is 15. Now we have to do our keep, change, flip. Keep. So this is like step 2. So keep 15 over 4, change, and flip. And then your last step is just multiply right across and divide, and simplify. So let's multiply right across. This is step 3. So we have 15 times 8. Don't know that off the top of my head. 8 times 5 is 40. 8 times 1 is 8, plus 4 more is 12 over 4. And now if you were to put this into long division, we have to figure out how many times 4 goes into 120. 4 goes into 12 3 times, which is 12. Bring down our 0. And then 4 goes into 0 0 times, and there is no remainder. So your answer should be 30. I hope this video was helpful. Feel free to go back. I try to do one of every example, but of course, if you ever needed any support, I am here for you. Thank you.